Hello students, how are you? Hope you all are fine. Welcome in the Mishra sir classes. Today we are going to deal with a new lesson, that is gravitation. It is a very well known term to you all. You all might have heard it many times. First of all, gravitation. What is gravitation? Gravitation is a type of force. What type of force? Non-contact force. Non-contact force. Non-contact force means you can say action at distance. Yes, action at distance force. But still it is not clear that what is gravitation. It is a force which exists between two bodies. It exists between two bodies. Yes, it is attracting force. Means this force exists between two bodies, and due to this force the objects attract each other. So now let us fine tune it. What is gravitation? Gravitation, it is a force by which any two objects attract each other. This is the force which has made many things possible in this universe, like rotation of Earth in the free space, orbiting of the moon around the Earth, existence of all the living and non-living things on the Earth. These things have been possible due to this force, and this fact was revealed by Sir Isaac Newton. Actually, Sir Isaac Newton observed a falling apple from the tree, and he questioned himself, why did it fall downward? Why didn't it go up? Yes. And so after several experimentation, he come to formulate law and define this force, gravitation. So the force of gravitation is an attracting force which exists between two bodies. It is applicable not only on the bodies of this planet Earth, but also in all the bodies which exist in this universe, whether it is microscopic or gigantic. There is no any effect of the state of the matter on it, whether the substances or the objects are in solid, liquid or in gaseous state. This force exists among objects. Now, my dear students, let us discuss Newton's universal law. Newton's universal law of gravitation. Newton's universal law of gravitation states that everybody in this universe attract another body by a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Once again, This law states that every object in this universe attracts another object by a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let us understand it by this mathematical deduction or derivation. Suppose there are two objects. This is object A, this is object B. It has mass m, it has mass small m. The distance from the center of both the object is d. Now, in this situation, what is the force of gravitation which exists between these two bodies? So, according to the Newton's universal law of gravitation, the force of gravitation between these two bodies is directly proportional to the product of their masses, that is capital M and small m. You can also write m1, m2, the same thing, and the force is inversely proportional to the square of the distance between them. So these are the two equations. Now from these two equations, from 1 and 2, we get, combine it, it will be F proportion capital M small m by d square. Now remove this sign of proportion, take a constant to make it equal. So now F equals G capital M small m by d square, where G is gravitational constant, where this capital G is gravitational constant. Now this G, which is gravitational constant, it has got a value, numerical value 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is its numerical value. You have to remember it. This value has been obtained by calculating the force of gravitation between two objects made up of golden sphere having the mass 1 kg kept at a distance of 1 meter. Actually that is not needed to be explained here, that's why it is not being explained. In higher classes you will get to know about this. You have to only use this value of gravitational constant while solving numerical problems of this chapter. That is why there is no need of raising much query from where did it came. My dear students, now this unit Newton meter square per kg square, yes, you have to know it, how we got it. So here you got F is equal to G m by d square. So G m will be equal to F into d square. G is equal to, you can write F into d square by m into m. Yes. Now SI unit of G, SI unit of this capital G will be equal to what? SI unit of force, that is Newton, into SI unit of distance, that is meter square, meter into meter, it is d square. So for one distance has got its unit meter, as it is a square, so we have used a square here, so don't get confused for that. Now G is equal to, here meter into mass into mass, the unit of mass is kg into kg is equal to Newton meter square per kg square, or you can write Newton meter square kg inverse square. Both are same thing. So this is how we have got the unit of gravitational constant G. Now why this law of gravitation is called universal law of gravitation? It is called universal law of gravitation because it is equally applicable in all the objects of this universe, whether it is terrestrial or celestial, whether it is microscopic or gigantic, whether the object in solid, liquid or gaseous form. That is why this law exists in all the objects of this universe. Thus it is called universal law of gravitation. Now F is equal to G capital M small m by d square. So you need to understand what is the relation of these entities with force. So here this is constant, this gravitation, it is constant, mass of the object is also constant. So all these terms are constant here. So distance is generally, mass is constant. If these things are constant, so it has got a relation with distance. Now distance can be increased or decreased easily. So what happens when the distance between the object increases or decreases? So that you need to know. As you can see, it is in denominator. So the denominator has got this d has distance has got an inverse relation with this force. So it means if the distance between the object increases, the force existing between them decreases. If the distance between the object decreases, the gravitational force existing between those two objects will increase. Now with the product of the mass, so this G has got a constant value 6.67 into 10 to the power minus 11 Newton meter square per kg square. But the mass of two objects, it may vary. Sometimes you may take the mass of earth and mass of a stone, sometimes you may take mass of sun and mass of this planet earth. So in both the cases the gravitational force will be different. Why it will be different? Because here it is in numerator, so force has a direct relation with the mass of the object. If the mass of the object increases, then surely the force of gravitation existing between those two objects, that will also increase. So I hope it might have cleared you. Once again I am repeating it. The force of gravitation existing between two objects is directly proportional to the product of the masses. It means if the product of mass increases, the force will increase. If the product of the masses decreases, the force will decrease. Another thing, that force existing between two objects depends on the distance between them also. If the distance between those two objects increases, it means it is going to decrease the force, because it has got inverse relation, indirect relation. If the distances between the two objects decreases, so decrease in distance will cause increment in the force existing between those two objects, because it is in indirect relation. Now let us see it. What happens to gravitational force if the distance between two objects is doubled. Now, so if the distance is doubled, it means there is no any change in mass will remain the same. So for that, first of all you have to find out F1. with actual mass and distance. So actual, let m be, let mass of first object is equal to, let capital M, mass of second object is equal to, let it be small m, distance is equal to d, then F is equal to g m by d square. This is first case. According to question, ATQ, according to question, if it is doubled, distance is doubled 2d, mass remains, masses are masses are capital M and small m respectively. It means it is as it is, there is no change. So in that case, that F2 will be equal to g capital M small m by 2d square. 2d square is equal to g m small m into 4 not into, by 4d square. So here you got F2 is equal to g capital M small m by 4d square. This is second case. Now you have to compare it, both the forces, this F1 this F1 and this F2 must be compared. So by comparing F1 and F2, what you will get? Let us compare. By comparing 1 and 2, F1 by F2 is equal to g capital M small m by d square upon g capital M small m by 4d square. Now is equal to g capital M small m by d square into, now inverse it, 4d square by g capital M small m. This term cancel each other, d square cancel. Therefore you have got F1 by F2 is equal to 4. Gm1 m2 by d square, distance 2d, distance increase 2d, it means by 2 by 2d. Here you have to, here you make a correction. Now it is 4d square, gmm by 4d square. gmm by 4d square. So here what happens now? In conclusion, you can say F2 into 4 is equal to F1. So F2 is equal to 1 by 4 F1. Here you have seen that the F2, it means after changing the distance, the original force or the initial force has been reduced by how many times? 4 times. The force reduced, you can write decreases by 4 times. So in this way, when you are asked what happens when the distance is halved, this was the case in which the distance has been made double and masses have been kept constant. But when you are asked what happens to the gravitational force when the distance is halved, then you have to use the first distance d, and in the second case the distance will be equal to d by 2. So in that case the force will increase 4 times. Here it has reduced, but when the distance is halved, the force will be increased by 4 times. You can calculate in the same way. Now my dear students, importance of gravitation. Actually, importance of gravitation we have discussed already in this video, but yeah,